Wasted food has nutrients worth saving. Here's how Divert gets them back to the soil. Commercial food waste contains packaging that standard composting systems often fail to remove through manual source separation and shred into smaller particles that cannot be removed by their own screening processes, leaving plastic contamination in the finished compost that ends up on farmland. Divert's process gently separates organics and packaging, sending the organics through advanced contaminant screening to return a cleaner, nutrient rich digestate to farms near its facilities. In this post, why commercial food waste is a significant source of plastic contamination in soil, how anaerobic digestion can produce nutrient rich digestate without the high plastic contaminant load found in conventional compost, why local digestate application matters for soil health and farm resilience, how Divert's process mitigates plastic contaminants before nutrients reach farmland and promotes circularity in the food system, what farmers and regulators can expect from partnering with a circular diversion program. The soil problem hiding in commercial compost. Farmers and agricultural regulators have long treated compost as a net positive for soil health. It adds organic matter, feeds microbial communities, and reduces dependence on synthetic inputs. Those benefits are real. But commercial compost made from packaged food waste carries a contaminant that most operators don't measure and most buyers don't ask about: plastics. Plastic contamination enters the composting stream through the packaging that surrounds commercial food waste, such as poly bags, cucumber shrink wrap, and produce stickers. Research published in the Journal of Hazardous Materials in 2025 found that composting process itself, which relies on shredding to encourage decomposition, increases microplastic abundance and shifts the particle size distribution towards a smaller, harder to detect fragments, meaning the finished product that reaches a farm can carry a higher microplastic load than the feedstock that went in. Plastic contamination of any size is a problem. Recent third-party testing of commercially available compost in Washington state found physical contamination 6 times greater than the state's allowable plastics limit. Additional physical sift screen testing found physical contaminant levels amounting to approximately 1 cup of contaminants from each 1 cubic foot bag of finished compost. Land applying this compost across a typical 445-acre farm would be the equivalent of micro-landfilling farmland with 240 cubic yards of contaminants, or 60 40-yard dumpsters full of plastic contaminants. The consequences for soil are not cosmetic. Greater volumes of plastics in agricultural soil disrupt nitrogen and carbon cycles, alter microbial communities, and can inhibit seed germination and nutrient uptake in crops. These are biological systems that determine whether a field is productive. Commercial food waste arrives heavily packaged in plastic film, rigid containers, and composite materials, and in volumes that make manual separation impractical. How that material is handled through any diversion pathway determines how much plastic contamination carries through to the finished output. How anaerobic digestion captures nutrients and mitigates contaminants. The nutrients locked in commercial food waste don't disappear because a product couldn't be sold. The challenge is finding a pathway that recovers those nutrients without delivering excessive plastic contamination along with them. Anaerobic digestion is a biological process in which microorganisms break down organic material in the absence of oxygen. Among its outputs are digestate, the nutrient-rich solid and liquid material that remains after digestion is complete. Digestate from food-based feedstocks typically contains 1.5 to 6.2 grams of total nitrogen per kilogram, along with retained phosphorus and potassium. Peer-reviewed data shows that digestate improves soil structure, supports moisture retention, and stimulates microbial activity when applied to farmland. Anaerobic digestion on its own does not automatically solve the contamination problem, though. What goes into the digester determines what comes out. This is where Divert's process diverges from standard practice. Divert's High-Recovery Depackaging is a custom-engineered system that maximizes organics recovery and minimizes inorganic contamination in 2 steps. First, by separating organics from outer packaging without shredding or pulverizing the incoming material, macroplastics are removed rather than being shredded into smaller pieces. Once separated, the organics pass through a fine liquid screening process using multiple screening steps to mitigate incidental remaining contaminants. Off-the-shelf depackaging systems typically shred or pulverize incoming packaged food and rely on dry screening, which lacks the resolution to capture finer particles. Divert's screening fidelity is finer than all current state regulatory thresholds for physical contaminants by particle size, while screening fidelity for common off-the-shelf depackaging and composting equipment often fail to meet these same regulatory thresholds. In third-party physical contamination testing, Divert's digestate-derived products outperformed comparable compost products, with physical contaminant tests showing 0.0 contamination rate. Because plastic is removed at the outset and the filtering steps for incidental contamination are high fidelity, what reaches the digester is food, and what exits as digestate reflects that. A nutrient profile drawn from the food itself, not from the packaging it arrived in. Divert is also able to recover nitrogen in a liquid form after digestion, offsetting reliance on synthetic fertilizers. Divert's solid and liquid digestate from clean food-based feedstock supplies necessary micronutrients and rebuilds organic microbial diversity, all while reducing a farm's exposure to the plastic accumulation that repeated compost application can produce over time. Keeping nutrients local. Recovering nutrients cleanly is one part of the equation. Where those nutrients go next is the other. Digestate transported hundreds of miles to reach farmland trades one inefficiency for another. Transport adds cost and emissions, and it severs the connection between the supply chain generating the unsaleable food and the agricultural land that could benefit from it. A circular system works best when the loop is short. Nutrients extracted from food that moved through regional supply chain should return to regional farmland as fertilizer and soil amendment. Agricultural operations close to a divert facility, such as Western Milling and Creme Brulee Farm Co. in California, receive fertilizers produced from food grown or distributed within the same area. That geographic alignment matters for several reasons. Shorter haul distances reduce the carbon footprint of the amendment itself. Farmers and agronomists can build an ongoing relationship with a consistent, documented input rather than sourcing compost from feedstocks with variable and often unknown contamination histories. For regulators tracking organic waste flows under state organics management laws, local digestate application is also easier to verify and document than long-distance material transfers. Divert has processed more than 4.2 billion pounds of wasted food to date and is scaling infrastructure to expand nationally. As that network expands, more regional food systems gain access to a nutrient return pathway that avoids the emissions of landfill disposal and mitigates the plastic contamination trade-off of conventional compost. What this means for farmers and regulators. For farmers, synthetic nitrogen fertilizer is effective at supplying macronutrients, but its production and use carries a significant emissions burden. A 2022 peer-reviewed study in Scientific Reports estimated that synthetic nitrogen fertilizer accounted for 1.13 billion metric tons of CO2 equivalent globally in 2018, roughly 10.6% of all agricultural emissions. Solid digestate and liquid fertilizer from food-based anaerobic digestion supplies the same core macronutrients and can also contribute organic matter that synthetic inputs do not provide. The agronomic effects go beyond the nutrient label. Digestate application improves soil structure, increases moisture retention, and stimulates microbial communities. These are the indicators that determine long-term field productivity and resilience to drought and compaction. An input that arrives from a feedstock filtered for plastic contaminants upstream is a meaningful distinction from compost products whose contamination history is often unverifiable. Repeated application of contamination-laden compost accumulates plastic load in the soil profile over seasons. Switching to a cleaner amendment does not undo prior contamination, but it stops adding to it. For regulators, state organics management laws, including SB 1383 in California and HB 2301 in Washington, require commercial food waste generators to divert organic material from landfills and, in some cases, to document where that material goes. ReFed estimates that 23 million tons of surplus food still reached U.S. landfills in 2024, generating over 600,000 metric tons of methane. The gap between current practice and compliance targets remain large. Closing that gap requires a robust organics processing industry where composters and anaerobic digesters can manage feedstock best suited for their operations under clean purity standards. Divert provides certificates of discretion, volume data, and ancillary documentation that supports regulatory reporting. Digestate and fertilizer application to local farmland creates a verifiable end use record. Organics materials diverted from the landfill, processed to mitigate plastic contaminant pass through, and returned to agricultural land within the region. Learn more about Divert's approach to soil health. Divert works with food businesses across the supply chain to prevent wasted food, optimize donations, and convert non donatable unsold food into renewable energy and fertilizers. If you manage farmland near a Divert facility or oversee organic waste compliance for a food business, contact us today to learn how Divert can create value for your operation by leveraging a truly circular food system.